Good afternoon, grade nines. We have got quite a quick lesson today, which is nice because it is Friday. So happy Friday to all of you. I will be posting some rebus puzzles on the Google Classroom after I post this lesson. So today we're just going to be discussing where the opposite of what we did last lesson. The last lesson we did addition of polynomials, and now this lesson we're going to be subtracting polynomials. I'm going to jump right into it, and like I said, this should be a pretty brief lesson. We only have a couple examples to have to do. So please make sure that you're emailing me. You guys have actually been doing a very good job of emailing when you have questions. You can email me or you can leave comments on the YouTube videos or on the Google Classroom if something isn't making sense. And that way I can, kind of guide you through and help you in the right direction. So let's get started. Last lesson, if you haven't watched it, go back and check it out on the channel. We talked about the addition or adding polynomials and how our main kind of technique was to group like terms together. And in order to know what it looks like to group like terms, you have to know what like terms are, which was the lesson even before that. So you can't just skip to this lesson. You have to watch all the lessons in order to know all of the content that is going on. So when adding, we removed the brackets, collected the like terms, combined the like terms, and then added up the coefficients. So we're going to do the same thing here, but we're going to subtract instead of adding. So how do we subtract polynomials? There's one really key thing that ends up happening is you have a negative that ends up being in front of a big group of brackets or a big group of, terms inside of brackets. And that gets a little bit confusing because that negative ends up making its way through each of these terms. So what ends up happening is when we subtract polynomials, we end up adding the opposite terms inside of the brackets following the subtraction sign. In other words, we change the subtraction sign into a plus sign. Then we change the signs of the terms inside the brackets of the second set of polynomials. Then we remove the brackets and add like normal. That's kind of just like a one way to think about it. I'm going to show you what's actually happening and how it ends up doing that. So what I mean by that is if I followed this exact set of rules, I would get negative 2a squared plus a minus 1. And then what I said was change the subtraction sign to a plus sign, then change the sides of the terms inside the second set of brackets. That would become negative a squared. This would become positive 3a, and this would become negative 2. And that's right. But I don't want you to just follow that rule mindlessly or aimlessly. I want you to know why that occurs. So what ends up happening is this negative sign gets put in front of the a squared, in front of the 3a, and in front of the 2. Now, it's just like multiplying a negative 1 throughout all of the terms there. And what we end up getting is negative 2a squared plus a minus 1. And if I put that negative through the whole way, I end up getting negative a squared, and then negative, and then that negative goes in there. So negative 3a, and then plus negative 2. Now I'm just going to put brackets around where these negatives went in there, and it ends up looking like that. And this right here is where it gets kind of confusing. That's where that plus kind of comes in. You still need to make sure that they're not added. So what ends up happening then, if I take away these these brackets, I get negative 2a squared plus a minus 1 minus a squared. Two negatives makes a positive plus 3a, and then plus minus gives me negative 2. So if I take the brackets away up here, I get the exact same thing, negative a squared plus 3a minus 2. So that's where it comes from. So whichever way you feel more comfortable, that's how you can do it. But the next step is to combine the like terms. So the a squareds come together, negative 2a squared, negative a squared, and then the a's come together, plus a and plus 3a, and then the numbers at the end, -1 and -2. So our last step is to just do our actual subtraction or addition. -2 minus 1 gives us -3a squared, and plus a plus 3a should give us 3 plus 1 should be 4, so plus 4a, and then -1 minus 2 gives us -3. So there's your final answer. And we would get the exact same final answer up here if we did it this way as well. So it's up to you. If you want to use that little technique of switching the sign and then switching the signs on the inside, that's fine. If you want to look at it as the negative sign kind of making its way through all of the terms inside of the brackets, you can also do that. This is technically what's going on. This rule does work. So it's up to you, okay? Let me know which you end up going with and which you end up liking more. And let's do one more example together. This is a trinomial subtraction that has two variables. And then it says to check our answer. In order to check your answer, you're going to have to plug in some values and add the difference to the second polynomial. I'll show you. So we're going to subtract. Let's do our first step here. This negative sign comes in here, -8x, -7xy, and then negative again for y squared. So what this is going to end up looking like is, let's say 5x squared minus 3xy plus 2y squared. And then we'll put this negative in front of the 8x squared, and then minus, and we'll put the negative in front of the 7xy. Sorry, that bracket needs to go there. And then minus, minus again, minus 4y squared. So we moved that negative over here, so that makes this a positive, and that negative is right there now. There we go. So we'll get rid of all the brackets now. So this is equal to 5x squared minus 3xy plus 2y squared. Plus minus gives us minus 8x squared. Minus minus gives us a plus 7xy. And then minus minus gives us a plus 4y squared. What is always my next step after that is to combine my like terms. Let's start with the x squareds. So I get 5x squared minus 8x squared. And then let's put our xy's in the middle. Minus 3xy plus 7xy. Minus 3xy plus 7xy. And then our y squareds. Plus 2y squared plus 4y squared. So now we've combined all of our like terms. Let's do our simple addition now, or subtraction, whatever it might be. 5 minus 8 would give me -3x squared. -3 plus 7 should give me plus 4xy. And then plus 2 plus 4. So it's kind of funny how a subtraction problem all of a sudden turns into an addition. That's just because we have double negatives going on. Plus 2 plus 4 gives us plus 6y squared. Okay, so there is our final answer. I'm going to put a square around that. Right there. Now, there is a way to be able to check your answer for these. In order to check your answer, you're going to have to plug in the final answer. What you basically said was this minus this equals that, right? So in order to check your answer, you can add the difference that you got, so the final answer you got, you can add it to the second polynomial. And if that ends up equaling the first, then you know that your work is right. So you actually don't even have to plug in any random numbers into this. You can do it that way as well, and it should end up being equal. I'll do it both ways. So the first way, imagine that this was this simple. If I said this whole thing was A, and this whole thing was B, and it was equal to C. So if it was A plus B equals C, well, then that would have to mean if I move my B to the other side, A would have to be equal to C minus B, right? That's all I'm saying. I'm going to do that right now. I'm going to take this and I'm going to subtract this. And if I do that, I should get this. So we'll try it. We'll have negative, so this is our C, so negative 3x squared plus 4xy plus 6y squared. And then we'll go minus, and then we're subtracting it, but this whole thing is minus. So minus 8x squared minus 7xy minus 4y squared. Almost ran out of room. What ends up happening is this right here just turns into a positive. Minus minus becomes positive. So what we end up getting is negative 3x squared plus 4xy plus 6y squared. And then all of this is just plus. So plus 8x squared minus plus minus is just a minus. So minus 7xy plus minus is a minus. So minus 4y squared. Combine your like terms. So negative 3 plus 8 with the x squareds. I'm going to put some equal signs here so we know that we're ending up saying that this is equal to this. And then we'll do our xy's. So 4xy minus 7xy. And then we'll do our y squareds. Plus 6y squared minus 4y squared. And if I do this, I should get what I got way up at the top here for A, right? We did say that C minus B should be equal to A. Let's double check. Negative 3 plus 5 should give me 5x squared. So far, so good. Plus 4 minus 7 should be negative 3xy. And then plus 6 minus 4 should be plus 2y squared. And there you have it. 5x squared minus 3xy plus 2y squared is the same as our A. So we have successfully checked our answer. That is equal to what we said was A. So that's one way to check your answer, okay? Another way that you can check your answer is you can write out, this way might take a little bit longer, a little bit trickier. You write out the whole thing and you plug in a number for X and a number for Y, and it should end up equaling the same thing. I'm going to set it up for you. I want you to try this on your own, okay? And we will pick it back up on Monday, and you can let me know if it ended up working out. So what you would end up with, if you did this, is you would have 5x. You know what? I'm going to choose an entirely different color here, and then you can try it on your own. So you would have 5x squared minus 3xy plus 2y squared minus 8x squared, I'm going to run out of room here, minus 7xy minus 4y squared. And all of that is equal to negative 3x squared plus 4xy plus 6y squared. So what you can do is say, for example, you can say, okay, let x equal 1 and let y equal 2. Those are pretty easy numbers to start with. Plug in x equals 1 and y equals 2 throughout this entire thing, and you should get that your left-hand side of your equal sign is equal to the right-hand side of your equal sign. And if you did it right, it should all check out, okay? So give that a shot and let me know what you get, and we'll go through the answer together on Monday. Monday is when I'll be having my live meeting with you guys. I pushed it back from today because of some conflicts of interest with staff meetings as well as with my grade 12 physics class. So we'll do it on Monday for the time being. For the weekend, you can try to work on some of these textbook problems, and you will have more time on Monday to do those as well. Okay, so pages 234 and 235, 5A, C, E, and G, all of 6, all of 7, 8, A to D, and then 10 is just a one-part problem or a two-part problem. So give that a shot. Let me know if you have any questions, and have a great weekend. We'll talk to you later.